All right, so I've been getting a lot of questions about how to do these problems. I already posted problem one answer key, so look at that to help you out. Please sure to take notes as you're watching that video from Mr. Buyer. It'll help out if you take it and pause it so you can make sense of it as it's going. But let's take a look at number two here. Number two is the one that's the most complex out of the three problems. So let's start. So the first thing we want to do, right? The first thing we want to do is split up this shape, this polygon, this regular pentagon, to five triangles. And regular just means that the sides are congruent and the angles are the same, right? That's what regular means. Sides are the same, angles are the same. So we split it up, and we want to figure out what is one of these central angles, right? What is one of these central angles? Let me zoom in a little bit here. And so what we want to do is, let's take this and let's look at this triangle more closely, right? So how do we figure out, and this is 12, right? Because each of these are 12. How do we figure out what this angle is? Well, we know this, right? We know that each of these angles are the same angle, right? Because they're the same. And we know that if we add these angles up, right? We add these all up, they should be a total of what? They should be a total of 360 degrees. So by knowing that, we can solve for this angle here. So 360 divided by 1, 2, 3, 4, 5. 5 angles, right? 5 central angles. Now, I believe in Mr. Byer's video, he does it a little bit different, and I'll show you what he does differently. And so let's take a calculator, and let's figure out what is 360 divided by 5. 360 divided by 5 is 72. So that means this, right? It means that this triangle here has an angle of 72 degrees, right? And this is still 12. That's very important. That's what we need to establish, that angle there is 72 degrees. Now, in Mr. Byer's video, he went ahead and did this right away, because you could do that, right? You could do that. We want to work with right triangles. So what we want to do now, right? What we want to do now is take this triangle and let's cut it in half so that we have two right triangles. And so by doing that, right? That by cutting this in half, that means that we now not have only just 5 triangles. We have 10 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. So instead of doing 360 divided by 5, we could also do 360 divided by 10. But what I did was I like to do it this way so that we have 72. And then we can divide the 72 by half, right? Now we can do 72 divided by 2. We get that each of these angles here, right? Each of these angles right here is 36 degrees. So that's one way of doing it, right? That's one way of doing it. You can do what Mr. Byer did, which is do 10 triangles, because we have each of these triangles here, and then we divide the triangles by 2 to get right triangles. So that means a total of 10 right triangles. But I like it this way. Now, here is the important part, right? We just want to focus on one of these right triangles. So I'm going to just do this again, right? Let's just focus on one of these right triangles. And we know a lot about right triangles because we did a lot of work with right triangles. To be able to solve for this area here, because remember, we want to solve for the area of this whole thing here. But we don't know how to do that yet. We need to figure out what the area is, what are these triangles here. Meaning, we got to figure out what is the area of one of these triangles, so we get the area of these triangles. How do we find the area of a triangle? That's going to be very important. The area of a triangle is equal to 1/2 base times height. So that means that I got to know what the base is, and I got to know what the height is. Where's my height? Here we go. I got to figure out what the height is. I got to know what these two things is, right? So depending on what the shape is, right, in the given length, I think in the first problem we were given the base already. So we didn't have to find the base. All we need to do is find the height. So, but this problem here is the most complex problem. We got to get the base and the height. So how do we do that? Well, we got to pick which one do we want to do first. Let's go ahead and do the base first. So how do we solve for the base here? Well, we don't have 3 side lengths, so we can't do Pythagorean theorem. What's the other tool that we learned? We learned about trig ratios. What is trig ratio again? SOHCAHTOA, right? SOHCAHTOA. And we want to look at these letters here, because these letters is sine, cosine, and tangent. And I just want to draw this again for us. What is SOHCAHTOA, right? SOHCAHTOA is opposite, adjacent, and hypotenuse. That's what each of these letters mean. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, and adjacent. So based off of what's given to us, we're going to use one of these ratios. Okay? So let's take a look. What are we given here? So to solve for the base, we're given the opposite side and the hypotenuse, right? We want to solve for b. We got to use this 12 here. So which ratio uses opposite and opposite and hypotenuse? Opposite and hypotenuse is sine, opposite, and hypotenuse. So we're going to be using sine. The sine ratio is sine theta equals to opposite over hypotenuse. Okay? So let's set it up. Okay, let's set it up. So sine theta, our angle is 36, equals to opposite, which is the b, times the hypotenuse, which is 12. Now how do we solve for b? We can cross multiply, but we can just do times 12, because we want to get rid of the 12 here, so b is by itself, right? So we times 12 to both sides. These 12 goes away. Remember when we was doing this? So 12 times sine of 36 is our base. And so we got to use a calculator to help us do this. Alright, so here's my calculator. Remember, you got to be sure that our mode is set to degree. I'm not sure if we have a calculator at home, but if you're using it on your phone, just be sure that the calculator is set to degree first, not radians. So we're doing 12 times sine of 36, 7.05. 7.05 is our base, right? That's the base right there. So we got the base, and let me highlight this so that we can use this later. Now let's get the height. Got the base, now let's get the height. I want to draw this triangle again so that this is isolated. So I'm drawing a triangle over here. 36, I want to get the height, and we know this is 12. You can definitely use this number here, but let's not do too much. Let's just focus on these two things here. But we already know what b is, so we can use it. We can put that there if we want to. Like if we put that there, right? Then we use Pythagorean theorem, right? We can use Pythagorean theorem if we put this 7.05 here. And so you can do that if you want to. But I'm gonna just stick with trig ratios, right? I'm gonna just stick with trig ratios, but you can definitely use Pythagorean theorem. So doing the same thing again. Circle my angle, I go across. That's my opposite. Notice that there's nothing there. So this is adjacent and hypotenuse. Those are the two sides that are given or what we want to use with. So adjacent and hypotenuse is this right here. Cosine, adjacent, hypotenuse. So we're going to be using cosine theta adjacent over hypotenuse. Let's set it up. Cosine theta is 36, equals to adjacent, which is h over 12. Same thing, right? We're doing the same thing again. Times 12 to both sides to get rid of that. That goes away. H equals, let's put this into the calculator. Or we can write it over again. I like to write it over again. Cosine of 36. And so this is 12 times cosine of 36. That gives us 9.71 approximately. 9.71 approximately. Let's round that. So we get H is approximately 9.71. This is approximately 2. Right, so we got the base, we got the height. Now we can kind of get ready to do these other problems. So, I was going too fast, and what I wanted to do was kind of do some steps here, right? So this is the first step, which is to draw the triangles. And then isolate the triangle, right? Isolate the triangle, get the angle, right? And then split it up again, right? Split it up again. And then we do, we solve for h and b, right? Solve for h and b. That was the 6th step. Now let's get ready for the 7th step. Let's do the 7th step right here. Alright. We got the base, we got the height. Let's draw this thing. I'm gonna draw the big one, right? The big triangle, not the small right triangle. Let's draw the big one. So we know this already. We know that each of these right here is 7.5, 7.05, right? See that? And we know that the height is 9.71. That's the height. So that means that this total base is, well, let's add that up. I think